You are part of the Harvard Black Hole Initiative, which has theoretical physicists, experimentalists, and even philosophers. So let me ask the big question. What is a black hole from a theoretical, from an experimental, maybe even from a philosophical perspective?
So a black hole is defined theoretically as a region of space-time from which light can never escape. Therefore, it's black. Now, that's just the starting point. Many weird things uh, follow from that basic definition, but that is the basic definition.
What is light that can't escape from a black hole?
Well, light is, the stuff that comes out of the sun, that stuff that goes into your eyes. Light is one of the stuff that disappears when the lights go off. This is stuff that appears when the lights come on.
Yeah.
Of course, I could give you a mathematical definition, but or physical mathematical definition, but I think it's something that we uh, will understand very intuitively. Uh, what is light? Black holes, on the other hand, we don't understand intuitively. They're very weird. And one of the questions is about black holes, which I think you were alluding to, is, why doesn't light get out? Or how is it that there can be a region of space-time from which light can't escape? It definitely happens. We've seen those regions. We have spectacular pictures, especially in the last several years, of those regions. They're there. In fact, they're up in the sky, thousands or millions of them. We don't yet know how many. But the proper explanation of why light doesn't escape from a black hole is still a matter of some debate. Um, and one explanation, which perhaps Einstein might have given, is that light carries energy. It carries energy because, we have photo cells and we can take the light from the sun and collect it, turn it into electricity. So there's energy in light. And anything that carries energy is subject to a gravitational pull. Gravity will pull at anything with energy. Now, it turns out that the gravitational pull exerted by an object is proportional to its mass. And so if you get enough mass in a small enough region, you can prevent light from escaping. And let me flesh that out a little more. If you're on the Earth and you're on a rocket ship leaving the surface of the Earth, and if we ignore the friction from the air, if your rocket accelerates up to 11 kilometers per second, that's escape velocity. And it can, if there were no friction, it could just continue forever to the next galaxy. On the moon, which has less mass, it's only 7 kilometers per second. So, but going in the other direction, if you have enough mass in one place, the escape velocity can become the speed of light. Mm-hmm. If you shine light straight up away from the Earth, it doesn't have too much trouble. It's going way above the escape velocity. And but if you have enough mass there, even light can't escape the escape velocity. And according to Einstein's theory of relativity, there is an absolute speed limit in the universe, the speed of light, and nothing makes any sense. Nothing could be self-consistent if there were objects that could exceed light speed. And so in these very, very massive regions of space-time, even light cannot escape.
And the interesting thing is Einstein himself didn't think that these objects we call the black holes could exist.